Here we discuss the amazing repeating, sometimes also called recurring decimal numbers. Hopefully, after 10 years from now, particularly after enough people watch this video, we move the concept of repeating decimal out of all algebra textbook, but move to pre-calculus textbook. Here we recommend our own pre-calculus textbook. Generally speaking, our suggestion is that move the discussion or learning repeating decimal numbers to pre-calculus courses. So let's recall that all numbers in the form of this fraction form, P over Q, where P, Q are integers, and denominator Q is not zero, those numbers are called rational numbers. If you do so-called decimal expansion, there's another definition, says that every rational number is either a terminating decimal or a repeating decimal. And this is the definition I do not like it, because in order to explain this kind of a definition, we need to understand, is this fraction 1/3, for example, equal to this repeating decimal 0.333? And why? Why are they the same? Well, since the division is the inverse operation of multiplication, so this 1/3 equal to the repeating decimal, this equation actually is equivalent to say 1 equal to 3 multiply 0.333. So we need to convince people two things. First of all, we need to convince that 3 multiply 0.333, first step said this actually equals to 0.999, or this kind of new repeating roots decimal. And second step, we have shown that this 0.999, this repeating decimal, is equal to 1. So we'll come back to the first step shortly. So let's first examine step 2. So to show 0.999, this repeating decimal equal to 1, there's a smart algebraic way. Maybe it's due to William Byers, according to Wikipedia. Here's the link. So the smart way is the following. Suppose you let x equal to 0.999, this repeating decimal. So you can multiply both sides by 10. This is formula 1 we listed here. And then you can split this line out of this decimal. You split this line out. We call it formula 2. And then recall this by definition. 0.999 actually is x. Okay, the formula 3 just to repeat x equal to 0.99. And the formula 4 said you can minus both sides simultaneously by x. So you got a 9x because 10x minus x is 9x. The right side is just 9 left. Finally, it's just dividing both sides by 9. So you got x equal to 1. Therefore, 0.999, this number equal to 1. Unfortunately, there are two serious gaps in this argument. First of all, let's observe. In formula 1, the so-called distributive rule cannot be applied to the so-called infinite summation unless you know this infinite summation is convergent. Sometimes we call this summation a series. In formula 2, similarly, so-called associative rule cannot be applied to the infinite sum unless you know the summation is convergent, unless you know this series is convergent. So there are two major gaps you cannot. So therefore, without understanding limit, it is very, very difficult to understand this argument. Okay, maybe this is wrong. So to understand the second gap clear, you may try the following things. Say, for example, you may try to argue to figure out what is this number? 1 minus 1 plus 1 minus 1 plus 1 minus 1. You may say, oh, this should be 1. Why? Because you say, well, maybe I can basically split this one out, and then you add these two numbers together. So that is negative second number plus third number, fourth number plus fifth number. So this is came here. And this equal to 0, second and the third, and fourth and the fifth equal to 0, and this also equal to 0. So you can see only one left. Therefore, you say, oh, this summation actually equal to 1. However, other people said, wait a second, you can argue this way, but I can use the associative rule in other way. Means that you can basically associate these two numbers together, and you can associate this 1 minus 1 together, and the plus 1 minus 1 together. So that is like this, 1 minus 1 plus 1 minus 1 plus 1 minus 1. And each of these terms equal to 0. Then you may wondering, this also equal to 1, equal to 0. So whether it is 1 or 0, it's uncertain, right? Well, the reason basically is that you cannot apply associative rule to these infinite many summations. Obviously, you can see to show 3 multiply 0.333, this repeating equal to another repeating, obviously, this so-called distributive rule also is misused. Okay. Well, the good news is the following. The good news is that this 0.999 actually equal to 1. However, it should read as following. It should read like the left side limit equal to the right side number 1. So because this really represents the series. Whenever we say this series equal to 1, we basically say this series converges to 1. So given all this kind of potential problem, you may wondering, should we still teach our students in middle school or high school this so-called repeating decimal or not? Maybe we should wait until we teach them what is the limit, what is the infinite series in the pre-calculus course. By then, it will be much easier for them to understand this repeating decimal number.